This week on BSD Now, we cover the Papers We Love conferences with a paper by Bryan Cantrill about the ARC. We're also going to cover SSD caching adventures with ZFS. We also show you how to do full disk encryption setups on OpenBSD and FreeBSD. And there's also a Perl Slack daemon which will show you all your messages from the syslogs in this week's episode of BSD Now. BSD Now, episode 219, We Love the ARC, recorded on the 18th of October for the 8th of November 2017. Hi, I'm your host, Benedikt Reuschling.
And I'm Alan Jude.
Whoa, this is...
And I'm in Taiwan right now.
Alan's not here. Just ignore Alan. He's not here. It's just a virtual representation of him. Going right into... Going right into the headlines for this week is something from the Papers We Love conferences. Mm-hmm. And it's from Bryan Cantrill, an all-time favorite of the BSD Now show interviews. And he's talking about the ARC, which is a self-tuning low-overhead replacement cache being used in the ZFS file system. Alan, take it away.
Yes. So this is Papers We Love is kind of like a user group meeting. I think it happens about once a month or whatever. And they pick a speaker and a particular paper and kind of discuss it and have the fun that is talking about these ideas. So previously we had covered, Bryan had done one in New York that we found very interesting. But this is Papers We Love about the ARC from the San Francisco chapter of Papers We Love. So at Usenix FAST, which is the File Systems and Storage Technology Conference in 2003, these two researchers presented their paper, ARC, and a self-tuning low-overhead replacement cache. And it's been used in a bunch of different things, including ZFS as part of Illumos and FreeBSD, and so on. Bryan's presentation is about an hour and 45 minutes. It's a full deep dive into the paper and the technology behind it.
You won't be bored.
Yeah. So if you've ever wondered how the ARC, the cache in ZFS works and why it's so much different than the typical, buffer cache you see in an operating system, then this is your chance to find out. And on top of it, it's presented by Bryan, so it will be fast-paced and interesting. So we have the links to the slides and the video, but it starts actually by looking back at the fundamental paper from the 1940s describing what a computer is or how it would work. In particular, this is from the Preliminary Discussion of the Logical Design of an Electronic Computing Instrument, published in 1946, and says, insomuch as the completed device will be a general-purpose computing machine, it should contain multiple main organs, a term that never caught on for computer parts, related to arithmetic, memory storage, control, and connection with the human operator, and so on. And it also had this other interesting quote about, there will therefore force to recognize the possibility of constructing a hierarchy of memories, each of which has greater capacity than the preceding, but with much less quickly accessible. Right? So then we get like the L1 cache, and then the L2 cache, and then your last level cache, and then you have RAM, and then you have stuff on disk. And then even that, especially in ZFS, we've abstracted that, so we have, NVMe, and then SSD, and then spinning drives, and then maybe tape. And you get all these hierarchies as you get bigger and bigger storage for less money, but every time it gets slower. And so you have to decide when to use which one. Mm. So it walks through the whole history of it and then starts looking at what some of the other caching algorithms were. So it actually starts with one called min, which is actually the optimal one. So min replaces the pages that has the greatest fork distance to be optimal in terms of the hit ratio. So this one requires predicting the future. So obviously it's not something you can actually implement. However,
Yeah.
by looking at the data after the fact and calculating what it would be, you can figure out what the best possible caching ratio would have been. And that gives you something to compare your caching ratio to. So then it looks at the typical one like LRU, which is basically least recently used. So you have a list of the blocks, and every time you use a block, it goes to the top of the list. And when you want to add something to the list, if the list is full, you delete stuff from the bottom until there's enough room to add the new thing at the top. Then you have something like an LFU, or least frequently used, where you keep track of how often a thing is used and cache based on that. So the thing that's used not very frequently falls off. The problem with this is, what if you delete a file? You used it a lot, but now you've deleted it. It's going to stay in the cache for a long time and waste that part of the cache.
Yeah, cache
And some other
invalidation.
problems. If you just, even if you don't delete the file, if you just stop using it a lot, it's not going to adapt very fast. And then you get things like LRU2, but then it's got logarithmic complexity and it gets complicated. And then they invented LRFU, where you try to combine the two. And then there's the adaptive LRFU, to which Cantrill says AYFKM. And then there's a multi-queue one designed for storage controllers, and he has comments about that, and then all these other designs. And then somebody's theoretical solution to this is the multiple experts. What if we just took the 12 best caching policies and used all of them and then just pick the winner every so often? Switch to the one that's working the best. It's like, well, that would require you to implement and debug all 12 of them and keep them all working all of the time. Plus all the overhead, which would probably make it so slow it wouldn't be useful.
Yeah, so you have to pick the best solution for this specific problem here.
Yeah. And then go on and talking about how that works, and then the invention of ghost caches and how that works. So the biggest difference with the implementation we have in ZFS, instead of having one cache of the most recently used blocks, we end up with 4 caches. One of the most recently used and one of the most frequently used, and then a ghost cache for each, where we keep track of blocks that have fallen off the end of the list, and we keep them from jumping back on the list. Right? Where you were on the list, but you weren't used enough to stay on the list, so we jumped you off. If we temporarily blacklist you and give someone else a chance, maybe they'll stay on the list. But if you keep ping-ponging back and forth, maybe it turns out it'll be best to keep you on the list. And because, you used just frequently enough that you keep ping-ponging out of the main cache. And it talks about that and about the actual implementation and then the results they got and so on. Like I said, it's an hour and 45 minutes, so it gets all kinds of detail going on. So you can learn a lot about the algorithm, not just the actual implementation in ZFS.
Yeah, and it's also worth checking out the actual paper.
And some of the related papers, which they highlight at the beginning here. And then, because Bryan is Bryan, he gets into how it actually works today and what problems he is currently dealing with having to do with it. So he's got this nice little graph of one of his systems at Joyent. I think this one's running a Postgres database. And you can see the Arc's doing pretty well, and it resizes and does okay. But then we run into this right about here. We run into this problem where the system tries to free some memory. You see this kind of faint line in the background. That's the queue of the kernel memory caches being freed. And you see the amount of free memory, the red line goes up. But during this whole dark area, the system is basically not hung, but not doing very much work. And then the system recovers, and then it hangs again. And then the system works too hard and ends up freeing like 40 gigs of memory when it
All
didn't
at
need
once?
to. Yeah. Well, not quite at once, so you can see it's a curve, but
Yeah.
yeah.
But in total.
It's like, everybody hold on, stop the bus, I'm going to free 40 gigs of RAM, and then you can continue. It's like, I only needed like a gig. You don't have to do that. Anyway, it's all described in the video, and it's quite entertaining.
Mm-hmm.
And
only the way Bryan could do it. Yeah, this is certainly
and it'll be interesting to see those fixes end up in OpenZFS as well.
Mm-hmm. Very nice. So yeah, if you want to get your weekly dose of Bryan Cantrill, then by all means. And also, there have been other conference papers at that conference about other papers they love.
Yeah,
so
Papers We Love, I think, is at least once a month, if not more, and they have it in New York and San Francisco and a few other places. So there are lots of other talks there. We'll have to go through there and pick out some other interesting ones as well.
Yeah. So whoever said that academic papers are boring and put you to sleep pretty quickly, there are some nice ones out there that are actually...
You just need the right presentation to go with it. And then suddenly...
That's true, yeah. It's what you make out of that.
Yep.
All right, yeah, check this out.
And there were some interesting questions from people in the audience at the end as well.
Oh, good. Very nice. So our next story is a question over at unixstackexchange.com answering how do I use man pages to learn how to use commands. So we like this one because it's very thorough and offers different approaches. And so the original question was basically about a question about xargs, but it's not asking for help with xargs in this case. It's more looking for help interpreting a man page to understand complicated commands. And how do you approach this if you haven't used the command before and want to know about how it works from the man page? So the answer that N. Wildner gave on Stack Exchange is the one we'll cover here. So he starts with, well, basically, his personal way to read man pages is have in mind what you want to do. When doing your research about xargs or whatever other program you want to look up or command, you did it for a purpose, right? You had a specific need that was reading standard output and executing commands based on that output. But when I don't know which command I want, what do you use then? So there's man-k or apropos, which is pretty much equivalent. Man-k is probably shorter to type. And so if you don't know how to find a file, man-k file, and then pipe that to grep and then search for a specific term, and read the descriptions and find one that will better fit your needs. So there's an example here with the apropos command, searching for something that has report in it, and that already gives you a bunch of man pages that might be interesting or the exact thing you're looking for. And apropos works with regular expressions by default. And of course, there's also a man page for apropos. And on this example, he's looking for every man page where the description starts with report. And next is always read the description before starting. So take a time and read the description. By just reading the description of the xargs command, you will learn that xargs reads from standard in and executes the command as needed. This also means that you will need to have some knowledge of how standard input works and how to manipulate it through pipes to chain commands together. And that the default behavior is to act like bin echo. So this gives you a little tip that if you need to chain more than one xargs together, you don't need to use echo to print. And we also have learned that a Unix file name can contain blank and new lines, that this could be a problem, and the argument -0 is a way to prevent things exploding by using null character separators. So things like that are all in the man page, in the description section.
Yes, in particular, if you're going to pipe find into xargs, always use find-print 0, all one word, and then the xargs-0, because that way file names with spaces or weird characters in them are not going to end up causing weird things to happen in the commands you're writing with xargs.
Mm-hmm. Yeah,
only way to be safe.
Yeah, you only do it once wrong, and then you figure out, this is the proper way to do this. And xargs will also stop if exit status 255 is reached. And he recommends don't even think of skipping this part of the man page. And he has another section, other things to pay attention to. So you can search for files using find, of course, and there's a ton of options. And if you only look at the synopsis, you will get overwhelmed by those because it's huge and the program can do a lot of things. It's just the tip of the iceberg. Excluding the name, synopsis, and description, you will have the following sections. Not in all man pages, but they are pretty common.
Most of them are in most of the pages.
Yeah. Authors, bugs, environment, examples, which are pretty very common in the BSD man pages, by the way. Reporting bugs to the authors if you find something that's not acting or working as it's supposed to. Copyright notice, and also also section which recommends other commands and tools or working aspects that are related to this command.
Yes. Half the time, that's how I remember the name of the command I forgot. It's like, I know there's a command that do this, but I don't remember what it is. So I look up something I know is related, and then look at the see also list.
Yeah, it's like Wikipedia. You jump from one to the next.
Yeah,
and
exactly.
End up somewhere else.
Or just like some tool I'm used to using or whatever, and I'm like, oh, it's related to this other tool I've never heard of. What does that do? It's like, oh, that's super useful.
Yeah. Another section is about the pager. So when you open a man page, it will be displayed by the less or more commands. He suggests you should switch to less wherever possible because less is more. If you are using Linux, you're probably served with your man infrastructure already configured because there's user bin less-is, which has its option explains in there, which you shouldn't go into here, which is not very interesting. Further down, he has a section when this method will not work so well. So in case man pages that have no examples or man pages where options have a short explanation only, and when you use generic keywords like and, to, for inside the man pages, and there's also a tip section that apply to all commands. So some options, mnemonics, and syntax style travel through all commands and reappear there, and you can pretty much make sure that these will reappear in others as well. So a popular example, or the probably most general one, is -v, which means verbose, and multiple V, like VVV, is a variation very, very verbose on some software. So it gives you debug information and more stuff you never want to use about internal workings. Following the POSIX standard, generally one dash arguments can be stacked, like in the tar example, so you can do -xzvf, or in CP, you can do CP-RV without having to write CP-R-V, so you can put these together. Generally, minus capital R and or minus lowercase r means recursive. Almost all commands have a brief help with the -- help option. -- version shows the version of the software. -p on copy or move utilities means preserve the permissions. And -y is also very common, means yes or proceed without asking you for confirmation. And don't get stuck if you do this thing in a batch job and doesn't require any input. There are also default values of commands. So at the pager chunk of this answer, so there's less-is mentioned again. And you can also do a slash and then type a word, which will search within the man page. This is good to know because that's what's supported by the pager. And his last section there is, and what about the synopsis syntax? So after getting all the information needed to execute the command, you can combine options, option arguments, and operands in line to make your job done. There's overview of the concepts. So options are the switches that dictate a command behavior. Do this, don't do this, or act this way, often called switches. Option arguments are used on most cases when an option isn't binary, like on and off, like -t on mount, that specifies the type of the file system, like -t ISO 9660, or in the BSDs, it's CD 9660. So do this with closed eyes, or feed the animals, but only the lions, also called arguments. Operands are things you want that command to act upon. If you use cat filename.txt, the operand is a file inside your current directory, and its the contents will be shown to standard out. ls is a command where an operand is optional. The 3 dots after the operand specifically or implicitly actually tells you that cat can act on multiple operands or files at the same time. You may notice that some commands have set what type of operand it will use. There's an example for the cat man page. It says cat, then in brackets option, and in another brackets file afterwards, and then there's the ellipsis dots. Yeah, this is a nice overview of how you read man pages or why you should read man pages in the first place, and also the proper way to read them and what sections you should pay attention to.
Mm-hmm. Yeah, so some good advice for newbies on how to actually use a man page.
Yeah, all things man pages, and you can revisit man pages if you just want to see what's the basic usage of the command. That's okay. And then you come back later and, there's a switch for more verbose or quiet option maybe. Or you want to have some other functionality and just read the man page and, search for certain things. And chances are it's documented, it's in there, the program implements it, and you will have gained much more knowledge about simple utilities. Okay, the next story in this section is my adventure into SSD caching with ZFS for a home NAS.
Mm-hmm.
This is Robert Putt in his blog, I guess. Yeah, seems like it. So
yes, this isn't fitting on my screen very nicely, but yes. Yes, Robert says, recently I decided to throw away my old defunct 2009 Mac Pro, which was rotting in my cupboard, and I decided to retrieve the only useful part that I had, an 80 gigabyte Intel SSD I'd installed a few years earlier to upgrade it. Initially, my thought was simply adding it to my desktop as a bit of extra space, but in 2017, 80 gigabytes really wasn't much, and then I had a brainwave. Let's see if we can squeeze some extra performance out of my HP Microserver Gen 8 NAS running ZFS by installing it as a cache disk. So he installed the SSD into the CD-ROM tray in the microserver using a floppy disk power connector to SATA power converter. Says, unfortunately, it seems the CD-ROM SATA port on the motherboard is only a 3 gigabit port, although this doesn't matter so much as this was an older 3 gigabit SSD anyway.
Okay.
He says, next, I boot up the machine, and to my surprise, the disk was not found in the FreeBSD install. Then I realized that the SATA port on the CD drive is actually provided by the RAID controller, so I rebooted into intelligent provisioning and added an additional RAID 0 array with just that one disk as a cache, or to act as my cache. In fact, all the disks on the machine are individual RAID 0 arrays, as it looks like just a bunch of disks to ZFS. Depending what controller that HP has, you might be able to reflash the firmware to make it not require you to do that extra step.
Mm-hmm.
So anyway, we get to the configuration. It says, let's look at the pool before adding the cache device. And you can see he has a pool called volume 0, and it has 2 sets of mirrors of 2 disks each.
Okay.
So he says, now let's prep the drive for using for use in the Z pool by using gpart. So he split the SSD into 2 separate partitions, one for the L2 ARC, the read cache, and one for a slog, or ZIL, the write cache. So he decided to split the disk into 20 gigabytes for ZIL and 50 gigabytes for L2 ARC. Be warned, using one SSD like this is considered unsafe because it's a single point of failure in terms of delayed writes. Your slog should probably be mirrored most times. And obviously, the SSD only has a limited throughput number of IOPS, and if you want really fast synchronous writes, you don't want to also be trying to read from the disk at the same time.
Mm-hmm.
Plus, depending on the type of SSD, using a slog on the SSD will wear it out pretty quickly. So you want to use a high endurance SSD. But your slog doesn't need to be very big. Even 20 gigabytes might be probably more than you need. And so don't spend a lot of money on a really large SSD for that. Although sometimes a larger SSD will have longer write
cycles
endurance. Right. So like thin or under provisioning a very large SSD to use a small bit of it for the slog means that as you wear out parts of it, you'll just be able to use other parts of the disk and it will maybe last longer. So anyway, you can see he partitions it that way. And then now it's time to add the cache and to see if it makes a difference. So you can see looking at the thing here, and then we just do zpool add log in the device and cache in the device. And you can see now that you have the two mirrors and the log and cache devices.
Okay. Seems straightforward.
Yes, so now it's time to see if it actually makes a difference. I suspect that it won't make that big of a difference because my NAS sucks. It's an HP microserver Gen 8 with a low-end Celeron CPU and only 4 gigs of RAM. That big of a L2 ARC with only 4 gigs of RAM is likely to actually make things worse. I'll explain why in a minute. So anyway, he says, let's test and find out. First off, let's throw FIO, which is a benchmarking tool, at the mount point of the soup pool and see what happens with the ZIL and L2 ARC enabled and disabled. And I'll also explain some other problems with the way that benchmark was done in a minute here. So he says, so the initial results is a little disappointing, but hardly unexpected. My NAS sucks and there's a lot of bottlenecks, CPU memory, and the fact that only 2 of the SATA ports are 6 gigabits per second, although with spinning disk, that probably won't matter so much.
Mm. Yeah, there's always a bottleneck, but the SSD should be the one.
So the biggest problem with the way they did the benchmark is they're doing 4K writes, but the record size on the dataset will be the default 128K. So they write 4K, and then when they go to write the second 4K, they're going to read the whole 128K, half of which is empty, modify the second 4K, and then write the whole 128K. Then read it, modify the third one, write it, read it, modify the fourth one, write it, etc. Most of that's going to come from the cache. The ARC is going to have cached that, so you're not reading it back from the disk every time, but it's still going to kill the performance. Where if you're going to run FIO with a 4K block size, if you create a data set, first of all, always start with a new data set for your benchmark because it'll be better. But if you set the record size to match the block size you're going to use in your benchmark, you're going to get a much more realistic result.
That's good to know.
At the same time, if you're going to use 128K blocks on and do 4K reads and write from them, the benchmark is going to be accurate that way too, right? It just means it's not going to give you very good performance compared to what you were hoping.
Yeah, it's not the actual way it works later on.
Well, if you're trying to run your MySQL database with 16K blocks on without setting the record size on the dataset, it's going to perform just as badly as the benchmark.
Yeah,
but
true.
If you set them up right, you'll get much, much better results.
True, yeah. But yeah, it's probably not what was intended to do with the benchmark.
So I might get time to play with this because I just got an Intel Optane 32 gig NVMe flash device to add a slog to my home NAS, mostly because I've never played with one before and it would give me a system to play with it on. So maybe I can make something happen here and show what the difference would be. Anyway, so he says, next he decided to test a few typical file transactions on the NAS. So sandwich shares from his workstation and so on. For the first test, I wanted to test reading a 3 gigabyte file over the network with both the cache enabled and disabled. I would run this multiple times to ensure data is hot in the L2 ARC and to ensure the test is somewhat repeatable. The network itself is an uncongested 1 gigabit link, and I'm copying onto a secondary SSD on his workstation. The dataset for these tests was compressed and deduplication disabled. Yes, you have to watch out. Compression can really throw off your results because it can give you impossible numbers sometimes. Other thing, the fill rate on the L2 ARC is probably the default, which is 8 megabytes per second with a boost of a second 8 megabytes per second, which can result in really slow filling of that L2 ARC. Because ZFS is trying to help you not wear out the L2 ARC. But if you're loading it that slowly, you might not have actually cached that whole file to the L2 ARC like you thought you did just by reading it 3 or 4 times.
Yeah. So you can manipulate this via sysctls or?
Yeah. And because the other thing is the file only goes in the L2 ARC if the cache on the main arc overflows or whatever. So you might actually, to test this, you might want to actually create a data set where the primary cache property is set to say metadata only or off or none or whatever the setting is. And the secondary cache, which is the L2 arc, is turned on. So it's only ever cached to the L2 arc. And that would allow you to compare, say, what would have likely been a more interesting benchmark in this case was comparing using the arc and the L2 arc, maybe having no caching at all and caching only off the SSD.
Mm-hmm. But you would do the full cache, not just the metadata.
Right. Anyway, looking at his speed results, he got a relatively modest boost from using caching. I think that likely is partly because his caching, the L2 arc probably didn't have the whole file in it because his filling technique was probably not good enough. Then they did a write test and found that the slog, so people keep calling it a ZIL, the ZFS intent log is not a feature you can turn off. The ZFS intent log is always there. When you have a slog or separate log device, that moves the ZIL from being part of the pool to being on the separate SSD. So that SSD is called a slog, not a ZIL. But anyway. In his Samba write tests, he almost doubled the performance by having the slog. So that one definitely seemed like it made a big difference for him. Mm-hmm. So then he asks, is the slog in L2 arc worth it? He says, I would imagine with a big beefy ZFS server running in a company somewhere with a large disk pool and lots of users and multiple enterprise level SSDs for the slog in L2 arc, it'd be well worth the investment. However, at home, I'm not so sure. Yes, I did see an increase in read speeds with cache data and a general increase in write speeds. However, in my use case, it's dependent. In his use case, I rarely access the same file frequently. My NAS primarily serves as a backup and an archive data, and although the write speeds are cool, I'm not sure it's a deal breaker. If I built a new home NAS today, I'd probably concentrate the budget on a better CPU and more RAM for the ARC cache and more disks. However, if I had a use case where I frequently access the same files and needed to do so in a faster fashion, then yes, I'd probably invest in an SSD for caching. Of course, if you can afford more RAM, that's better.
Yeah.
He says, I think if you have a spare SSD lying around and you want something fun to do, sure, chuck it in your ZFS-based NAS as a caching mechanism. If you're planning on buying an SSD for caching, then I'd really consider your needs and decide if the money can be spent on, more RAM instead. I know my NAS would benefit from some extra 6 of RAM and a more powerful CPU, but as a quick evening project, it was fun playing around with the SSDs. The thing I will point out, the way the L2 arc works. So you have the arc, right? And when something gets cached, there's an arc header that describes the block and then the block of data. And that goes in RAM and makes things faster. Mm-hmm. When something's on the L2 arc, the arc header still has to be in RAM. And then instead of a data block, it says, hey, this data is over on the SSD.
It's a reference, yeah.
Yeah, a pointer to the SSD. So that means for every block of data on the L2 arc SSD, it takes up some RAM. So if you go and add a 1 terabyte SSD to your system with 4 gigs of RAM, the pointers to the stuff on the SSD are going to take up all the RAM.
Yeah.
And then you won't be able to actually cache anything in the arc part of the cache. So you're going to fill up your fastest cache with pointers to a slower cache.
Yeah,
and
which is still
likely
faster
make performance worse.
Oh, yeah. It's still faster than the disks, but it's still slower than the main memory.
Yeah. So, caching 10% of the workload on really fast RAM is probably better than caching 30% of the workload on a medium speed SSD. The point of an L2 arc is to give you more cache when you can't afford more RAM or whatever, but you still need to have a reasonable amount of RAM to cover it.
Yeah, with the compressed ARC, it's helpful nowadays. You can put more stuff into memory.
Yeah, but that mostly applies to the data. Although, and all data stored on the L2 ARC is compressed as
already?
well.
Okay.
But looking at some stats I saw from someone else using ZFS the other day, they had 512 gigs of RAM and something like 5 terabytes of L2 ARC. And so they were actually using 64 gigs of RAM just pointing to the L2 ARC. Now, for them, that makes sense because they can have 400 and something gigs of RAM actually doing ARC. But, if you throw terabytes of L2 ARC at your machine, you're actually going to probably make your cache worse rather than better.
Yeah, it would be interesting to look at this with the arcstat command, or what's it called, the zilstat?
ZFS-stats pulls up the arcstats out of the stuff, and it will tell you how much L2 ARC headers are being taken up, and that'll be the amount of RAM. That RAM is part of the ARC, not separate, so don't get too confused or think you're using more RAM than you have or something. If you have 20 gigs of ARC and it says 13 gigs of that is L2 ARC headers, that means that there's only 7 gigs of actual ARC going on there. And it's you maybe are making your performance worse rather than better.
Yep. So it's a good example for not only how to do benchmarks correct, but also performance tuning can also be difficult if you're not...
Yeah, so if you're going to run FIO on ZFS, make a data set and set it up for the benchmark you're going to do. If you're going to read and write 4K blocks, then set the record size to 4K. And if you want to test what a database is going to do, like MySQL, and it uses a 16K block size, then set the record size to that and tell FIO to use 16K blocks.
Yep.
And if you want to test the L2 ARC, you want to make sure that you're actually caching using the L2 ARC and that it's actually filling up properly and so on.
Yeah, but it would be nice to see this as a follow-up story maybe, or from someone else who did it the way it should be done, and then see what the differences are. And
yes, I will. I'm in the middle of expanding my home NAS from 6 disks to 12 and adding a slog for fun. So we'll see how that goes.
Okay, cool.
And of course, if you want to know which is the right SSD to use for your slog, or whether you need one or not, and so on, when you build the server, talk to the experts over at ixsystems.com. So go to ixsystems.com/BSD Now and get in touch with them and be like, hey, I want to build a NAS or a SAN or a storage server or hyper-converged appliance or whatever, and I need it to be able to do at least this many writes per second or this many IOPS or whatever. You really want to design for worst case scenario, what's the minimum number of IOPS I need? And make sure the machine can deliver that. And then when everything's not the worst case scenario, you'll get even better. But, when they sell you something that says up to this many IOPS, it's like, sure, on Magic Happy Day, when I get the maximum number of IOPS, that's great. But, the days I care about are not the Magic Happy Days.
Yeah. And these are the things that they put together because they have the experience. They built hundreds and thousands of these systems for customers to have specific I/O needs or specific, memory needs that needs to be satisfied because they are doing a number of throughput things, or have a cloud storage server need so that customers have a certain number of IOPS each time they access that system. So these are the systems that IX Systems built and has built and will configure the way the customer needs to have a proper solution tailor-made. Yeah,
you really, because they actually understand how ZFS works and so on, you want to get in touch with them and explain what it is you're trying to do, and they'll help you build the right system for it. Whether that's picking the right kind of SSD for the slog and a different kind of SSD for the L2 ARC, because, one's read heavy and one's write heavy and so on. but also just sizing things. It's like, what size of L2 ARC makes sense? If I have this much RAM, it's like, well, you might be better off by spending more money on RAM and less money on the SSDs and fitting more into it.
Mm-hmm. Yeah, so check out IX Systems and tell them exactly what you need to build or what your solution will hopefully look like, but they will also tell you what you shouldn't put in there or which components work less well together, and they recommend you something else that they've tested out and know that it works.
Yeah, also, if you check out their blog, they have the Drives for Days server MV machine still up there. If you want to drool over somebody else's NAS, here's one with 60 drives added to it. Each one is 10 terabytes of the Hitachi Helium Ultrastars, giving 600 terabytes of raw storage. And you can see it's got dual power supplies, 2 SSDs for the operating system, lots of fans.
Of course.
High-speed networking, all the fun stuff.
That's one big ZFS pool, I guess.
Yep. It's got 8 sticks of 16 gigs of RAM each, a dual 10-core Xeon processor, and the 2 800-gig Intel SSDs for the operating system, and the dual 2,000-watt redundant power supplies.
That's certainly a beefy system. Yeah, so these are the systems that IX Systems can build, depending on what use case you're trying to solve. So in this section, we have normally this interview part, and we've done a couple of interviews with ourselves, and some of these questions were submitted to Alan only, so I'm taking the role of the interviewer here this week, and so Alan will answer the questions that I will quote him or ask him, because these are the questions that were sent in for Alan. The first one is, if you could no longer use Unix-like systems, what operating systems would you use?
What operating systems exist that are not Unix-like?
Yeah, good question.
DOS and Windows, maybe? I don't
What's left?
If I couldn't use Unix-like systems anymore, because I guess they didn't exist in this mythical universe or whatever, I would definitely say Plan 9 is Unix-like, but anyway. Probably Windows, but I would also probably not do computers professionally anymore. I would find something else to do.
It turns people away from the fun of computing.
Yeah.
Okay. Next question. What part of the FreeBSD operating systems are you most fascinated with?
I think there's a couple. I like storage and stuff, and so Geom, the whole storage subsystem and the way you can layer stuff in FreeBSD, I found that really interesting. And the other stuff is, I wouldn't say quite so much the VM layer as just the interaction, like send file and the way of shortcutting and sharing pages between right from a userland application through to the network stack, and my current naive efforts to hook that up to make it work for ZFS.
Okay. And also VFS, probably, if I may interject, copying from one file system type to another is also VFS job. The translation and
right. But UFS already works nice with send files, so this would be mostly my interest is ZFS in that case. But I would say Geom and almost all of the kernel, basically, but in particular, send file and Geom, I think, would be the highlights of what I'm interested in today, anyway.
Okay. And next question is, what is your favorite programming language?
I wouldn't say that C is my favorite, but it's what I've been doing most of my work in and probably will continue to do most of my work in now. I haven't played with many other ones. I'd like to learn Go or something, but I've never sat down and done it. So it's pretty much all been C lately, and odd bits of PHP still for work. I wouldn't say PHP is my favorite, but it is definitely the thing I've written the most code in over the last 10 years. Hopefully 10 years from now, that will be C that I've written most of the code in for the 10 years.
I look forward to that.
The other thing I've worked in lately is Java, but I'm not a fan.
Yeah, public static void main, whatever that is.
Well, that's just object-oriented. That I don't have a problem with so much. It's just Java in general, and also having a factory class, factory interface generator factory.
Integers. Yeah, this is, it's very object-oriented in this way. Okay. The next question is, what is the worst advice you've ever received?
I don't know. My immediate snarky answer is just use Linux, but no one's ever actually tried to tell me that. Worst advice. I don't know.
Don't go to BSD conferences? Well,
nobody told me that either.
That's probably no one will do this.
Maybe another snarky one would be like, you should meet Michael W. Lucas. He's a nice guy.
Yeah, I don't know what I would answer to this one, but yeah. Okay, let's leave it at that. Next question is, which project are you most interested in at this time?
Right now, I'm just finishing up the Z standard compression in ZFS feature. And also trying to help shepherd in the Geli boot support for EFI, although I'm not actually writing any of that code. I think the project I've been thinking about the most in the last couple days is improving the pipes in FreeBSD, making higher performance interprocess communications. Just looking at some patches that went into Dragonfly BSD. When was this? Like 5 days ago. That looked kind of interesting. Not quite the direction I was thinking of going, but would like to compare their method and my method and see how that goes. I've been talking with some people about that one. The idea originally came to me early this year while working on the new set of ZFS benchmarks for my talk at BSD Can, and found that the way I was doing the benchmarking, the reason why Netcat was not achieving line rate was actually because of the pipes. And by just redirecting to dev null instead of piping it through DD to measure the number of bytes and so on, suddenly I was going from 24 gigabits to 40 gigabits. And I was like, oh, so this is throwing all my benchmarks off, and I had to rewrite all the benchmarks and do it over again. And I was like, trying to finish this in time for the paper for BSD Can, while at the same time wanting to be distracted and dig into why are the pipes in FreeBSD so slow, and what can I do to make them faster? And then I came up with the start of a patch, and I was like, well, how does this impact different systems? And then I ran it across everything I have from Core 2 Duos up through the newest like E5 things. Like, I think I ran on every generation of the I series. So like Sandy Bridge, Ivy Bridge, Haswell, Broadwell, Skylake, and Kaby Lake wasn't out yet. And found different degrees of improvements. And then laptops have a different optimal value than other machines because they have less cache than a bigger machine, and servers, and so on and on. So yes, I think the project I'm most interested in at this time is improving pipes, which kind of, it's not the same, but it kind of relates to that whole send file thing I was talking about earlier in the other question. And then I kind of want to combine the two. I'm like, what if the ZFS send command could use something like send file to write directly to a socket instead of going through a pipe to netcat to go out the socket or whatever. Especially since ZFS send is originally coming from the kernel. So if you could send file it to a socket or whatever, then you wouldn't have to go into user space to do it at all. And then what performance number could you get with that?
Yeah, okay. So you'll turn into a plumber at one point, fixing the pipes. Yeah. So next question. How do you feel about systemd being nominated for a pony?
I thought that was well-deserved, I guess. So if you don't know, the ponies are these awards given out at, I think it's Black Hat or DEF CON. And in particular, systemd got one for the something if you set the username for something to start with a 0. So if the username was like
0 day?
Yeah, literally 0 day, it would interpret that because it converted it to an integer, it would interpret that as 0 and a bunch of garbage. And so user 0 is root. And so you could get root privileges by just creating a startup script that said, hey, run this program as the user 0 day. And then suddenly it would escalate you to running that program as root. And the response from the systemd maintainers was like, well, just don't do that, rather than, hey, we should actually check the return value on this conversion to integer to make it work.
Yep.
Yes, and in particular, it won the pony for lamest vendor response to a number of the CVEs that were filed because of that. And I can a little bit see where they were coming from, and some of it was like, well, just don't do that is not necessarily the wrong answer, but it does need to be fixed. You can't just close it as a won't fix or whatever. But yeah.
So well deserved, yeah.
Yeah. Root privilege is kind of a local root exploit is one of the less severe of the types, but it's still something that needs to be fixed.
Mm-hmm. Okay. The next question is, how do you feel about the possibility of migrating to another init system like OpenRC or Runit? I guess this is for BSD.
Yeah. Yep. I'm not very gung-ho about that. In general, I'm fine with what we have. I understand that why people want something better, but that's a lot of work. Now, TrueOS has done a lot of the work, but it's still not perfect in my use of TrueOS a little bit there. But just having to rewrite every init script for everything in the base system and then for every port. Now, some ports do come with them, but a lot of them don't. And it's a lot of work to do and upkeep and maintain, and there would just be a lot of breakage for a while during the switch. And I'm not sure I see the immediate benefit for a lot of it. I understand people want their laptops to boot faster and so on, but Colin's doing a bunch of work on parts where it's needlessly slow and could make a big difference. Now, a bunch of the bugs I've experienced with OpenRC have been fixed by now, but it used to be if my Wi-Fi was switched on, but I wasn't in range of a Wi-Fi hotspot or whatever, it would just hang for 2 minutes during boot and so on. Or other problems I had where basically I had to switch the Wi-Fi off during boot or it wouldn't boot properly. And for a while there, it would just randomly delete my WLAN 0 interface instead of setting up my Wi-Fi, and a couple other problems. I imagine most of my love for the current FreeBSD RC system just comes from years of experience with it and knowing the ins and outs of it, and I would get used to something else, but I'm not in a big hurry to go do something else. There are individual features from some of these other systems that I really like. A bunch of infrastructure would have to be built to do it, but the service command on the systemd based ones, printing a little bit of context from the log file when you restart the daemon to be able to tell what it was doing before and if it restarted properly, that would be super useful. But not if it requires making turning the log files into a binary format that you can't easily do other things with, and that can get corrupted. Whereas if, we just have a tag column or whatever in the plain text output that says the daemon name, you could easily suss out the bit of information you were looking for. So personally, I'm not motivated to help with it, but if TrueOS gets the conversion OpenRC to a point where it's actually really clean and all the ports are ready for it, and it's not going to be a really bumpy switchover where it's going to be 2 or 3 months of, oh, you rebooted the server and this service didn't start, and oh, your Wi-Fi stopped working and all this other stuff, I wouldn't object to switching to it, but only once it was really polished.
Okay. Next question. Oh, it's getting very dark now. If ZFS were no longer being developed in some sort of dystopian future, which file system would you most likely use instead?
Well, first, I would continue using ZFS for at least another couple of years because it's perfectly fine the way it is now. In particular, I imagine I would continue to use ZFS until something in the storage area changed to the point where ZFS just didn't support some feature or something that was actually needed. I don't know what that... Obviously, whatever that is doesn't exist today. And so I can't really talk about that one, but... I don't know what else to say. This is a horrible future. Why are you making me think about this?
Yeah.
If it's that far away, maybe Hammer 2 is ready to go by then. It seems to be coming along. The last time I looked at Hammer, though, it didn't solve the same problems as ZFS. It provided a bunch of the useful features, and like the being able to the not snapshots and being able to get old versions of files and stuff that were really cool. But RAID Z is the big feature that I care about, and making sure my data doesn't go away. And last time I looked, Hammer still was like, use hardware RAID for that. And I was like, if ZFS has taught me anything, it's don't trust hardware RAID.
Yep. Okay.
I'm not sure that's... Unless it were some type of legal issue, I'm not sure that would be possible, just because some FreeBSD people would keep working on it. There's a group of people I know that wouldn't give it up. So unless there was some kind of legal issue or just it was surpassed by something else. But nothing that's going to surpass it exists today. So in particular, ButterFS is never going to...
I thought you would go to this one, but yeah.
Yeah. I'm not going to use the better have a backup file system.
Yeah, okay. Yeah, let's leave this utopian future to a different parallel universe. Next question. Do you run a rootless Xorg, or do you not consider the security problems to be serious enough to worry about it in daily use?
I don't actually know which way I run it. I run it whatever the default is on FreeBSD. I install Xorg and I install the PCBSD login manager in Lumina. So when I log in, I'm logged in as my user, not root, but parts of the X server probably do run as root. I'm not sure. But no, I don't consider the security problems to be serious enough to worry about it in my daily use. I'd be more worried that trying to run rootless Xorg would make something not work, and that would just annoy me. In general, on my, I feel my security is better because I'm running FreeBSD instead of Windows on the desktop thing, and that the operating system not being an impediment to getting my work done is the most important feature to me. The threat environment for my office is not one of the things I worry about every day.
Oh, okay. There's a related question, the next one. On the same note, how interested in Wayland adoption on BSD are you?
I think most of my interest for that one comes from the fact that it seems Intel is only going to really worry about drivers and stuff for Wayland in the future. And so now that FreeBSD is finally getting caught up in graphics, I wouldn't want us to end up left behind again because Wayland wasn't being worked on. Luckily, there are some people in the FreeBSD ports tree working on it, but it's not something I think about very much right now. And maybe that's a problem, honestly. But if there's anything I can do to encourage the people working on Wayland, I will do it. But desktop-y stuff is not something I would choose to spend my time on.
Yeah, you have other things to worry about.
Outside of the web browser, I'm pretty much fine using the terminal for everything.
See?
Yeah. The Lumina is basically just a way to manage all of the shells I have open.
Yeah, it's just a wrapper around the whole shell thing. Okay, so the next question is, what's your basement power bill like? For example, in relation to the electrical consumption for the rest of the house. How do you track and account for the power used for your business?
That's a bit complicated. We don't meter it separately. I haven't looked at the latest bill. So my bill was
systems?
every 2 months, and then recently they changed it every month, and it's kind of changed what it looks like a bit. It about doubled the power draw for the whole house. And obviously things change as the weather and the seasons change. We use a lot less electricity in the winter because we don't have to run the second air conditioner in the basement. There's a separate air conditioner for the computer room, and that's mostly idle during the winter. It generally maintains the temperature fairly nice, and then once the temperatures get below freezing outside, which happens quite a bit in the winter in Canada.
This is Canada, yeah.
Then we can actually start just with natural aspiration, keeping the computer room below the house temperature, just by using a fan, basically. Whereas when it's positive degrees outside, it usually still requires a little bit of air conditioning to keep the amount of heat that we generate with the 6 machines from building up too much in the room. Cheat a little bit. When nobody's in the office, we often leave the door to the computer room open to let some of the heat spread out to the rest of the house.
Oh, isn't that loud?
Well, it's in the basement. So
right.
if nobody's in the office, which is in the basement, then yes. When people are working there, then the door gets closed because it's loud. But just the cheap little veneer door or whatever there stifles the high frequency noise to the point where when there's 3 of us sitting in the office, we don't even notice all the server noise. But if you open that door, you definitely do. Yeah. The tax implications of trying to write off the power use got to where they weren't worth the complexity of it. Basically, if the business paid me more to offset it, then I would have to pay tax on that, and it would mess up my taxes. And so we mostly don't deal with it that way to avoid the extra paperwork. But yeah, so it varies quite a bit, but it's not that bad. It can also depend on usage. You know, we have PowerD and so on running on those machines, so they clock themselves down and don't use power when they don't need to. The 2 biggest machines are full of hard drives, but they're generally pretty idle except for when we're running a backup. So they don't do that much. One of them is currently running as a puppet master and using a lot of CPU. We'll probably move that job to a different machine, and that will lower the power use in my basement a little bit, but it's not that big of a deal. where I live, it doesn't happen. The power's not exceedingly expensive. People living here would not agree with that, but when they compare to the price of power in California and so on, it's actually not so bad. I've considered getting some extra circuits put into that room just to separate things a little better and give more capacity, although I don't know that we'll put that many more machines in there. But I think the total draw in there is about 1,200 watts, I think, not counting the air conditioner. The air conditioner is harder to measure. All those machines are actually not being quite that terrible as far as power usage.
Okay. Well, if you say so. The next question is about, the whole Twitter story. We started a couple of years ago. Lately, I've been enjoying the Twitter conversations between Michael W. Lucas and Graf the BSD Goat on their Twitter handles, of course. I seem to remember you saying something about having to buy a stuffed goat on the way to some BSD conference, maybe BSD Can. Can you share Graf the BSD Goat's origin story? I've been introduced via Twitter to several BSD folks and conferences just by following Graf on Twitter. Just thought it would be interesting to find out how this started and how new keepers are selected.
Yeah. So I guess it was before BSD Can 2014. I think it was actually Sean Webb of Hardened BSD had tweeted that he had been practicing his presentation and had the timing down right, so it took the amount of time he wanted it to take. He just needed to sacrifice 2 goats to the demo gods so that when he did the live demo as part of his presentation, it would work. And then there was some tweeting going back and forth, and Michael Lucas got into it. And then I joined in and was teasing another podcaster, Brian Lunduke, because he has some pet goats that he keeps to eat the grass on his lawn so he doesn't have to mow it. And tweeting, just getting him in this thread that just kept notifying for a week. It was quite amusing. But eventually, at some point during that, I was nominated as the person to bring the goat to BSD Can because I lived in Canada and wouldn't have to try to bring a goat through customs. So at this point, the implication was to get a real goat and bring it to the pub for the opening night pub meetup. And I looked a little bit into it, but it was going to be kind of complicated, and I really didn't think the people at the Royal Oak would appreciate us bringing an actual goat into the restaurant. So a little bit of quick searching, and I found this nice little stuffed goat on Amazon and paid more for the priority shipping than I did for the goat to get it in time, and brought it with me to BSD Can. At the opening pub, which is the Tuesday before the conference, and the conference, the Dev Summit is Wednesday, Thursday, and the conference is Friday, Saturday. Graf was at the pub and got his picture taken with a bunch of people, and had quite a bit of fun. And the original idea was just to auction off this stuffed goat at the end of the conference for the charity auction, and somebody would take it home, and it would be, haha, that was funny. But Graf was so popular, and it became such a big thing that I decided maybe what we should do is take Graf to EuroBSDCon too. We don't want all the people that didn't come to BSDCon to miss out. So then it became, let's just auction off the naming rights. Somebody can pick the name for Graf. And that was actually John Hickson who suggested that one, because Bob Beck and the OpenBSD people wanted to name it Goatsy, and we vetoed that. So that's how Graf started. And then I don't know whose idea it was to have a keeper, and it's like, we'll give it to somebody and they'll take it to the next conference. Part of it was just that at that time, I didn't think I was going to get to go to EuroBSDCon that year. But I did end up going. But anyway, so that I gave it to Benedict, and he was going to take it. And then Benedict decided to start a Twitter account because he hadn't had a Twitter account, and he made one for the goat, and then started tweeting as the goat and invented this character for the goat. And it was just like the goat having an apple and so on. And it was quite amusing. And I thought that was pretty funny. So then at EuroBSDCon, I guess Benedict and I just decided we should give it to the next person. Do you remember who that was? I think it was Sean Bruno to go to MeetBSD?
Yeah, that could be, yeah.
Yes, because it was an even-numbered year, 2014. So yes, it went with Sean Bruno to MeetBSD, and then it went with Hiroki to AsiaBSD, and then
Brad Davis.
That would have been 2015, and then Brad Davis had it for a while, and then Deb ended up with it, and it went on and on and on, and it's been all over the place now. I do need to finish the Graph the BSD Goat website and write this whole story down and have the list of keepers and a little travel map of all the places the goat has been.
Yeah, and each person gave it their own personality, but Michael W. Lucas really upped that game. And
yes. Well, you know, he's a professional fiction writer, unlike the rest of us. But I still think Peter Hessler from OpenBSD has the best tweet so far with Graph having a bath.
Oh, yeah. And yeah, you have to see it too.
Yes. As far as deciding on how keepers are selected, that's generally not until the conference where we're giving away. So like at EuroBSDCon, it was just a conversation with me and Benedict, and the current keeper at the time was Michael Lucas. And we were like, you know, well, who's going to the next conference? And that we trust to be good with the goat and so on. And usually some people volunteer by getting in touch with us. And
we also try to cycle it between BSD projects so that it doesn't look like it's a free BSD goat, but it's a BSD goat.
Mm-hmm. Yeah. After Graph avoided a kidnapping attempt, Baptiste's girlfriend really wanted to Graph. So we picked Marius Zaborski to take it to BSD Taiwan because there are not all that many people that were in Europe that were going to Taiwan. And he was one of them. So we picked him. And then in Taiwan, we will find somebody who's going to Tokyo will be the next thing.
Yeah.
So that should be pretty easy.
Yeah. So follow the goat. It's Graph the BSD Goat on Twitter, and see what hilarity will happen in the future.
Yeah. And if you're going to be at BSD Taiwan, and you're definitely going to AsiaBSDCon in Tokyo this spring of next year, then and you want to volunteer, then do get in touch and let us know, and we'll take you under consideration. If there were too many people, Michael Lucas proposed that at the closing of the conference, they have to get up and give 1-minute speeches, and we'll have the conference vote on which one, or elect one of them to carry the goat. So if we get too many people wanting a turn, we have a system devised to decide who gets the goat.
GraphCon and all that, yeah. Okay, yeah, there will be certainly funny things happening in the future with a stuffed goat with more followers than many other people. Okay, next question is, how did the BSD Now podcast came to be, and how did the association with Jupiter Broadcasting came about?
Okay, so you can ask the second half in a minute. So I'll actually answer a slightly different question first, which is how did I first get involved in Jupiter Broadcasting? So I have had this IRC server I've been hosting for a very long time. And I periodically would look around and see what the biggest channels were and make sure everything was okay. And then suddenly one day, this small channel was really big. There was like 800 people in it instead of the usual like 70. So I poked my head in to see what was going on, wondering if it was some kind of bot attack or something. And no, it seemed all legitimate people. And then somebody named Jeremy, who I didn't know, asked, what is the name of Captain Archer's dog? And so I was like, that's easy, Porthos. And they were like, you win. I'm like, I win? What do I win? And it was for a previous podcast Jupiter Broadcasting was doing called Stoked, which was the Star Trek Online podcast. And they were giving away closed beta invites to the game. And so I had just won a closed beta invite to this game. And so I was like, oh, okay, you guys are kind of cool. What's going on here? I was familiar with podcasts, but I'd never seen this network before because they mostly had a show about Linux, which I wasn't interested in. Then, as things started going, the forum they had set up for the Star Trek Online thing was getting overrun with traffic. And the hosting company was like, you need to move off the shared hosting and get a dedicated server. That'll be this much, and we won't help you move your stuff. I was like, Jupiter Broadcasting, let's move that thing to Scale Engine's web hosting thing, because back then Scale Engine did web hosting and not video. Let's move it to us, and because we're specifically, the product Scale Engine sold then was hosting that could scale to handle, in particular, forums, like vBulletin and so on forums. And so we took over that, and it worked very well, and they didn't have these problems with the traffic, especially since, in their case, the traffic was going to go away once the beta was over and the game was out. There was going to be this giant crash of people trying to get these open beta invites and such. And then I ended up hosting the TeamSpeak on my server for it because that was a convenient way for everybody to talk to each other back then. And then eventually, one day the hard drive in their web server was dying, so we moved the main Jupiter Broadcasting site over. And then years later, turns out Scale Engine turned into a video streaming company, and that's when the blip.tv that they were using to host the downloads of the podcasts switched their model from $10 a month for unlimited bandwidth to, oh, that doesn't work, we're going out of business. And so they switched everything over to Scale Engine. And then over time, I think at one point I did a guest host, I was interviewed for the Linux podcast talking about FreeBSD 9 when it came out and explaining the latest and greatest features of BSD. And I kind of had fun doing that. And so I recorded a couple of offline segments that they aired during the show, especially on kind of their equivalent of Weeks Like Now, where one of the hosts was going to be away. They could just pad it out with this 20 minutes of Alan talking. And eventually that led to starting the TechSnap podcast, which I had done for 6 years until the beginning of this year when Dan Lingill took over for me. So I had been started doing a podcast on Jupiter Broadcasting that way. Then one day, it was actually in the Freenode FreeBSD chat room. I've been talking to this user named Blackheim, who is TJ, who eventually became the producer for BSD Now. Eventually got him dragged over to the Jupiter Broadcasting chat room, and we were talking, and one day he's like, we could do a podcast about BSDs. I was like, I suppose. I don't think there would be enough news to do a podcast about BSD every single week. Boy, was I wrong. So I was like, okay, go out and write the notes for 3 episodes. If we could find enough current news to make 3 whole episodes, then I think that we can keep that up and have an episode every week. And so TJ went and did that. And I was like, actually, this might work. And so I talked to the people at Jupiter Broadcasting and was like, so I know with most of the current podcasts, you record it in your studio. But if I have the right software here and get the mics and stuff, we could set this up and run it. Where I can record it here and just send you guys the files to edit and produce. And so we did that. And then I was asking around trying to get people find a co-host. And eventually, when I was talking to Drew about it, she recommended Chris Moore. And I was like, I would assume Chris Moore is too busy, but maybe not. I asked him and he was excited, and he did it for almost 200 episodes. And that was, I guess, the start of how we started. So yeah, it was TJ's idea. I didn't think there was enough news. He proved there was, so we started the show. We found a co-host, so Chris and I did it, and TJ helped write the notes. And then after, I think it was episode 100 or so, we replaced TJ with JT and continued. And then a bit before episode 200, we replaced Chris with Benedict because Chris's job started taking up too much time and he didn't have time to do the show. And that's how BSD Now got started. And that's why it's associated with Jupiter Broadcasting. Because at the time, I was already doing a podcast on Jupiter Broadcasting, so it made sense to have the second one be there. And I didn't want to have to edit the show or run the Twitter account or the website or any of that other stuff. So using their infrastructure just made more sense. It meant that they helped find the sponsors and set up those relationships, and that in general, I just have to show up with Benedict with our show notes, record the show, and then send the files off to them, and then not think about it anymore. Whereas if I tried to do the entire podcast with just me and Benedict and JT, the episodes wouldn't come out on time every week for sure. So big thanks to Rikai, the Richard Corman, who does the video editing for BSD Now, and actually making sure that the episodes come out every week on time.
Yeah, they're doing all the heavy lifting in the behind the scenes, and we're quite happy to have them without having to worry about cutting and show notes editing and all variation. So yeah, thanks to the Jupiter Broadcasting folks for all the stuff they're doing to make the show successful. Okay. Yeah, the second part of that question is, you probably answered it a couple of thing of them. So what's it like working with Jupiter Broadcasting, and how would someone else with an interest in creating a tech podcast work with Jupiter Broadcasting?
So for me, it was, the first podcast I did with that, I started by just being a guest on an existing show. And then one of the hosts of that show and myself started our own show and did that for quite a few years. And so when I proposed another podcast that didn't require them to do much extra work, they were kind of happy to do that. So working with them has been fine. They make the show happen, which is great. It wouldn't be possible without them. It would just be too much work for us. I wouldn't want to sap time away from a bunch of other BSD people to make it happen. And yeah, if you wanted to start another podcast with them, you would be best to get in touch with Jupiter Broadcasting directly. I don't know.
Okay. Well, go to the website. There will be contact information there, I guess. But yeah, start your own podcast. Why not? There's still many more things you could tell without just having one podcast covering it all. Okay, next and last question for this week. You own and operate a private company, write books, contribute to FreeBSD, and record podcasts with admirable regularity. Do you have a great memory and self-control, or perhaps a favorite system or tool to stay organized?
I have a terrible memory as far as remembering to do things, not necessarily remembering. I can remember information quite well, but remembering to do things doesn't happen very well. Not much self-control at all, no. Reminders on my phone for some stuff. The podcast is not so bad for organization. It's, it's every Wednesday at this time. And I've been setting aside a day a week to do a podcast for 7 years now. So I'm pretty used to it. It's part of my routine. The show notes, some weeks are better than others as far as getting the notes ready on time. If you've ever watched live, sometimes you'll notice the show starts about half hour late as we're still working on the show notes.
Yeah. Just in time.
Writing the books, the second one was delayed quite a bit because of me. So that's not necessarily a great example. That second book should have come out of quite a bit sooner than it actually did. For the private company, I don't have to do everything there. We have a number of employees and I only own half of it. So that makes it a little better than... I was very smart when I started the company. I allowed my business partner to have the title of president in exchange for doing the extra paperwork. So I get to be the vice president and have all the assigning authority, but half the work, or less than half the work. So that makes that a bit better. Biggest organizational tool for the podcast is this website, pinboard.in, which is just where I manage the bookmarks of stories I find as I'm reading the internet throughout the week and following BSD stuff. And I just mark it as I want to come back to this on Monday and Tuesday nights and put them in the show notes. As far as communication, we have an IRC channel that we use. Now that I've finally fixed Benedict's problems by making him use Puzzle, I can actually communicate with him reliably, and that makes a big difference.
Yeah.
No, I really need some better tools to stay organized. of course, the tools are there. I just don't use them. Yeah, I don't have any good answers for you. Biggest thing for the contributing to FreeBSD stuff is motivation. Just wanting to do it. I find it very interesting and exciting, and I mostly pick projects that I want to work on. That's one of the big bonuses of working on open source is you get to pick which part you work on. And so you work on something you like working on. And it's a lot different than my day job. And so I don't have to, my day job, I generally don't get to pick what I work on. I have to work on what needs working on. Whereas open source, I can be like, I'm just going to work on this thing that I find interesting. And, what are you going to do about it?
Yeah, there's no one bossing you around to finish in a certain amount of time. But it's a curse, but it's also, it's a two-edged sword here.
Yes, it definitely means there are gaps in open source where, hey, that's not interesting. Nobody wants to work on that. But it does mean that, from my perspective, it means that I get to work on whatever I happen to find interesting. And the other downside can be, though, I get something half finished and I'm suddenly not that interested in it anymore and I just never finish it.
Yep. Okay, yeah, so thanks, Alan, for answering these questions. Maybe next time it's my turn. And there was some new stuff in there from me at least. And yeah, thank you for answering these so honestly, and
thank you for the audience for writing in and asking the questions.
Okay, I hope you enjoyed this interview section between Alan and me, and we're now getting right into our news roundup for this week. The first item here is the setup OpenBSD 6.2 with a full disk encryption. So it's more of a screenshot tour, but it pretty much details all the steps you need to do. First, you, of course, start and boot the installation, and then after selecting your keyboard layout, in this case, because the blog is in French, or the author is French-speaking, he has a French keyboard layout, but you can pick any you like. Then you pretty much exit the installer with the exclamation mark. The second step is to prepare your disk for encryption. You figure out what kind of name your disk has. So it's in this case, it's an SSD, which has either SDO or WDO. Then you initialize the disk with fdisk. You provide a disk label for it and erase everything that's on the disk before. So you have a complete empty wiped disk. And then you need to use BioCTL on that to encrypt the partition they created. So it's going to be called, in this case, SDO. Oh, is it an O? Is it a zero?
It's a zero.
It's a zero, yeah. So it's a SD0A. For the partition A is the first, this one. Then you enter the passphrase, which is important, that you should not forget this, because it's the one key to get back your files on your disk, to decrypt them each time. Third step is resume the OpenBSD installer and basically follow the installation procedure. Fourth step is partitioning the encrypted volume, and because you want to have the whole disk encrypted, so you choose the whole disk to use. And then you create your partitions. You also start, in the fifth step, the system installation. There's a lot of screenshots here that you can follow along. And then you basically do the network install by HTTP, if you have that medium. The sixth step is to finalize the installation with some last-minute changes or some steps you need to do. The last step is, of course, the reboot and restarting your system. And when you do that, there will be a prompt popping up asking you for your passphrase. And that is the way you know that the system is working and it's a full encrypted disk, and no one can boot your system unless they enter the correct passphrase. There's also an optional section to disable the swap encryption, because the swap is actually part of the encrypted system, so they don't need to
encrypt it twice.
Yeah. So it's unnecessary work. And yeah, that's what this blog post details, and you can follow the screenshots along to do the setup on your own machine.
Yep. Or, same blog actually has the same instructions for FreeBSD.
Ah, excellent. Yeah, so people can choose which system they want to use, but it's in both cases fully encrypted at the end, and no one else could get to your files unless they know the passphrase.
Yeah. So first you need, what do you need? You need the CD image or the USB image, one of the two, and write it to your USB stick. And there's also a tool for Windows users, whatever. So then you want to boot, and you'll get the FreeBSD installer. And you can choose install, and then it'll ask you about your keyboard. So you can configure your French keyboard if you have one. Then you enter the host name for the system, whatever you want to call it. Then you choose which distribution sets you want to install. You can choose none or all of them or whatever set you want. Then if you have install media that does not contain the install files, so like the boot-only ISO or the mini mem stick, then you'll have to configure your network to get the files. And it'll ask if you want to do DHCP or not, and then give you your network configuration. It'll ask about v6, and get your IP address set up. You can enter your v6 addresses and stuff if you need. Set up DNS, and then pick which mirror you want to install from. So they choose one of the French IPv6 mirrors. Then you have your options for how to do the disk. So there's the shell option, similar to what they did on OpenBSD, or you can choose the guided wizard for UFS or the guided wizard for ZFS, or you can do it manually with the partition editor. So they chose ZFS, and you get this menu where you can select which disks, what you want to name the pool, if you want to encrypt the disks, and so on. So you set it to encrypt the disk. You select which disks you want to use. Agree that this will erase those disks. You type in your extremely long passphrase. Very nicely done there. Then type that in again. And then it will create the encrypted partitions for you. And then splat down a ZFS on top of those, and then extract the distribution sets you selected. Then you can enter root's password, select your time zone, select the date and time to make sure those are correct on your system. Select what services you want to start automatically. So, you want SSH and so on. Then there's these new hardening options that were added. And then you can choose to add additional users. You do want to do that if you want to be able to log in over SSH. I've been meaning to add a check at the end of the install that if you, when you create the extra user, you want to make sure that you also invite that user to the wheel group if you want them to be able to SU to root. And so I've been meaning to add a check at the end of the install that if there are no users in the wheel group, ask the user, are you sure that's what you want? Because you won't be able to log in over SSH. And giving them the option to go back and add a user to the wheel group so that they won't have that problem. I haven't got around to that yet. At the end of that, you're brought back to the main menu where you can choose to exit. And then you're asked if you'd like to drop into a siege root in the installed system to make any other configuration changes you want to do. If yes, it'll give you that, and when you type exit, it'll bring you back. And then you can choose to either remain in a live CD on the installer or reboot. And when you reboot, you'll be prompted for the passphrase. And once you enter that, it will decrypt the hard drive, and FreeBSD will boot. And that's all there is to it.
Oh, very nice.
I put a lot of work into making that process work nicely, so I'm glad that somebody was able to go through it and do it with nice screenshots.
Very nice. Yeah, people should follow that.
Yeah. And we've made it quite easy on FreeBSD now.
What's
This week's
also
episode of BSD Now is brought to you by DigitalOcean. Head over to digitalocean.com and take a look at what they have to offer. You can spin up a FreeBSD VM with UFS or ZFS for as little as $5 a month.
Yeah, it's a great way to start testing out your favorite BSD in the cloud or in a more evil internet. You can also select which kind of networking options you want to have. You want to have a firewall maybe or a load balancer between multiple ones. You can have floating IPs, which redirect the network traffic between any of your droplets, which is the VM name in the DigitalOcean cloud. So they can redirect the traffic between those droplets with the same data center using a floating IP and a static IP as well that points to one of your droplets.
Yeah, it makes it very easy to have, say, your web server, snapshot, clone it, upgrade it, move the website over to it, see if it works. If it doesn't, move the website back, all without having to change DNS or anything.
Yeah, this is super nice if you want to keep things running in the
basically
cloud.
CARP for multiple VMs. It's great.
You also get a lot of cool monitoring things on their website, like real-time summary dashboards, like how much CPU you're currently using or how much bandwidth you're already eaten into. So there's a lot of nice graphs so you can get a quick glance of what's happening in your
and they have load balancers and cloud firewalls and monitoring, like you mentioned, team accounts, which are super useful, command line and API access, DNS, worldwide availability. You can data centers all over the world. And those data centers all over the world are now directly connected by their own private backbone network. So whether your server is in San Francisco, New York, London, Amsterdam, Frankfurt, or Singapore, they can all directly connect to each other. Plus, they also have data centers in Toronto and Bangalore that will be connected early next year.
Oh, yeah. So they keep growing. Yeah.
They make it super easy.
Yeah. So check out DigitalOcean and don't forget to use the coupon code FreeBSDNow, which will give you a $10 credit. So you can use the first month and a little bit of the next one on our bill, and then you have enough time to experience the DigitalOcean cloud and the services they offer. All right. Our next story is the Anatomy of LDD program on OpenBSD, which is a little bit more into getting about, LDD and source code. So it starts with, in the past week, I read the LDD source code on OpenBSD to get a better understanding of how it works. And this post should also be a reference to other Unix operating systems.
Yes, so for those that don't know, LDD is a tool. You can point it at a binary and it'll tell you what shared libraries that binary uses.
Yeah, exactly. The ELF file, which is the executable linker format, is divided into 4 categories: relocatable, executable, shared, and core. Only the executable and shared object files may have dynamic object dependencies, so the LDD only checks these 2 kinds of ELF file. So there's an example here for the executable part. LDD leverages the LD_trace_loaded_objects environment variable in fact. The code is as follows. So here's a little code example how to use this with a setend call. And when that is set to either 1 or true, running executable files will show shared objects needed instead of running it. So you even not need LDD to check executable files because then you can just set this variable to true, and then you can see more about your program that you're running, the LDD program.
Yeah, make the program print it out itself. Of course, not quite in the same nice format as LDD.
Yeah. The second one is the shared object, and the code for that one will print the dependencies to shared objects as listed in our show notes here. And the question is why the condition of checking ELF file is shared object or not is like this. So if the hdr.etype is equals to the constant et_din, then this will check whether this is a dynamic file or not. And of course, if it's a position independent executable, which is abbreviated to PIE, it's the same as shared object, but normally position-independent executables contain an interpreter program header since it needs dynamic linker to load it while the shared object lacks. And there's an article detailing more about this. So here's a little example how this will look like. And of course, there's also a little main program that demonstrates this as a simple application which just outputs dynamic object information for shared objects that it's using yourself. And when you run this, you can see what kind of objects are linked into your basic program.
Yeah, you can see that libssl.so needs libcrypto.so.
Yeah, the dependencies are broken down in this one, and it's detailing where it's coming from and where it's located, the start and end sections. And when you use the LDD program directly on this, it will give you the same output. Cool, this is nice. So yeah, people can experiment a little bit more with LDD to see, and especially if a program doesn't work because it's missing a shared library, run LDD, and then you figure out, this one isn't listed because it broke during the update cycle or however it disappeared. So LDD is your little helper to show you which dependency is missing. Our next story is...
they had a nice little summary at the end, and they said, through the studying of the LDD source code, they got many byproducts, such as an understanding of the ELF file format, linking and loading and how that works. So dividing it into code is a really good method to learn Unix, is actually looking at a simple tool and trying to extract individual features out of it and run them as your own program and just kind of dissect how it works.
Right, yeah. This could be a teaching tool or a part of a section on program development.
Yeah, somebody asked me a question a while ago about getting a list of what file descriptors are open or something like that. And Procstat can kind of do what they want, but not exactly what they were looking to do. And so I just took the code from Procstat and changed a couple things and looped over it slightly differently and was able to do what they want. But it was an interesting exercise in learning how that works.
Yeah, it's also, I think it's a dtrace one-liner to list all of these. I think it should be on the FreeBSD wiki in the one-liner.
Well, this one was actually trying to extract a little bit more. They wanted to know, I think it was just how many file descriptors are open for each program and nothing else.
Okay, overall.
They didn't actually want the list or something, so it was easy to make Procstat do less work.
Yeah.
Making a program do less work is always easier than making it do more work.
Yeah, filter it down to what you need to know. Okay, great.
So next up, we have a Perl Slack Syslog daemon.
Sounds fun.
So I've been working on this little Perl daemon for about a week now, the author says. Is a simple syslog daemon that listens on port 514 for incoming messages. It listens on a port so that it can process log messages from his consumer Linux router, as well as messages from his FreeBSD server, or just BSD server. Messages that are above an alert priority are sent. They match a regex for anything of SSH or DHCP and so on. And the rest of the messages are not sent to Slack. But any messages that match the set of filters he has set up are actually sent into a Slack channel by the spot.
Cool.
He says, this is very handy so I can access to info like failed SSH logins, disk failures, new devices connecting to my network. So every time his DHCP server gives it a lease or whatever. And so you get a little screenshot here. You can see he has an alert channel on his Syslog Slack. And you can see that it says, he's got currently unreadable pending sectors on disk ADA0. So that disk is probably dying. And there's a failed login over his LAN for SSH and so on. It says, a situation arose today when the internet went down, and I thought to myself, what would happen to all those important syslog messages when they couldn't be sent? Before, the script only ran an eval block on the bot send function. The error So an error was returned, handled, but nothing was done, and the unsent messages were just discarded. So they added new functionality that appends unsent messages to an array that are sent later when the server is not busy sending messages to Slack. Because Slack has a limit of 1 message per second. The new addition works well. It means that if the internet fails, my server will store these messages in memory and resend them at a rate of 1 message per second when the internet connection returns. It currently sends the newest ones first, but I'm not sure if this is a bug or a feature. I can definitely see you don't want to delay new important messages to deal with a backlog of old unimportant messages.
Get the newest ones first.
Yep. So they say it currently works with their Linux-based Wi-Fi router and their FreeBSD server. And it's easy to scale as well, as you need to send messages to Syslog to get them to send to Slack. You could send, CPU temperature, logged in users, etc. And they have a GitHub page for the bot if you want to, fork that and make it do whatever you want to do.
Mm-hmm. It's all in our show notes, so yeah.
Mm-hmm. Yeah, I've had IRC bots that report server status and stuff to me from servers for 15 years now. Always been a handy thing to have.
That's what they do, yeah. That's what bots are for.
Well,
Okay.
The main reason I started with it was because I was selling IRC as a service, so it made sense to have bots on IRC that showed off the uptime of the servers and stuff like that.
Yep. Very nice. And while we're on this topic of GitHub, there's another interesting thing there, which you should check out, which is LSCPU for OpenBSD and FreeBSD. So this one is, it starts off, there's a neat command, LSCPU, which is very handy to display CPU information on GNU Linux operating systems. So it probably is known by some of our watchers and listeners. This is basically the CPU architectures and some other CPU information like byte order, little or big endian, or threads per core, cores per socket, how many sockets in total. But unfortunately, the BSD OSs lack this command. Maybe one reason is LSCPU relies heavily on /proc, which BSDs don't provide for a reason. Take OpenBSD as an example. If I want to know CPU information, dmessage should be one choice. So you basically grab for any CPU strings there, and then you can get some information out there, but it's still not that pretty and not nicely formatted.
Yeah, I don't know. I didn't scroll ahead to see if they did. On FreeBSD, there's sysctls in the hardware category, so HW dot, that have the model of the CPU and the number of CPUs and a couple other things like the amount of RAM and so on. In addition to the dmessage like output that you see there.
Yep. So yeah, it's messy output, and he writes, as for DMI decode, it used to be another option, but now can't work out of box because it will access /dev/mem, which for security reasons OpenBSD doesn't allow by default. And
that does still work on FreeBSD.
Yeah, it does. Maybe not with a higher security level, but in general, the lower ones. So there's a sysctl function. The BSDs provide sysctl interfaces, which can use to get general CPU particulars, such as how many CPUs the system contains, the byte order, and other information. The second one is CPU ID instruction. For the x86 architecture, CPU ID instruction can obtain very detailed information on a CPU. This coding work is a little tedious and error-prone, not only because I need to reference both Intel and AMD specifications, since these two vendors have minor distinctions, but I also need to parse the bits of register values. So the code is provided on GitHub, and the author hopes he would get some feedback and error reports maybe, or issues that came up, and maybe there's an extension possible for ARM or SPARC64, which would probably enrich his small program.
Mm-hmm.
So so check this out on GitHub, fork it, add some stuff to it, and then we have a much nicer CPU information on the BSDs as well. So after this little section, it's time for our BSD Bits this week. And starting with OpenBSD porting workshop by Bryan Callahan, who will be running that. So it's an OpenBSD porting workshop in New York City with the NICEBug on December 6th, 2017. So if you should happen to be in New York during that time, then yeah, drop in and there's a little porting workshop for OpenBSD.
Yes. Learn to port software to OpenBSD.
Very nice. So Brian's doing some porting work, hopefully getting some people involved. And the next story we have is also about OpenBSD. Learn to tame OpenBSD quickly. So there's a website, openbsdjumpstart.org. That sounds interesting.
And it talks a little bit about the history of OpenBSD, some of its innovations, how the version numbers work, what the different flavors are, how to get it installed, what some of the important files and commands are for setting up the network and routing and so on.
A lot of examples.
How to use the packet filter and get PF running the way you like. Links to that. How to add users, how to manage groups using doas, how to install packages, how to install non-free firmware images, how to manage your various daemons and what starts at boot up, how to update your stable releases with syspatch, and the file system and how that's laid out, where to find the various files you might be looking for, links to man pages where the kernel lives, all that kind of stuff, the RAM disk, sysctl, how to control what happens when you close the lid on your laptop, etc.
Yeah, a lot of information in there, and yeah, of course,
nice, quick step
layout
guide to using OpenBSD.
Mm-hmm. And they also didn't forget the sponsoring, how people can donate back to the project, either by the OpenBSD store or the OpenBSD Foundation.
Somebody should make a FreeBSD one.
Yeah, there's going to be a fundraising at the end of the year. So,
but I just mean a quick start guide to let people get started with FreeBSD.
Yeah. And for the other BSDs as well.
Mm-hmm.
Cool. Last BSD bit for this week is detect the operating system using UDP stack corner cases. So Alan found this on Twitter.
Yeah, so this one, based on, basically it creates a socket and then immediately tries to shut it down. And if it gets the no such system call thing, it knows that you're running on Minix. However, then if it then tries to connect the socket after it's been shut down, it'll get an error. On FreeBSD, it would say address not available. So then it would know it's FreeBSD. But if it doesn't do that, if it works, then you know it's Linux. However, if shutting down didn't work, or did work, then if we try to connect and we get that that's invalid, it's probably NetBSD. Whereas if we get that address family is not supported, then it is OpenBSD. And if it wasn't either of those, then it's probably Dragonfly. So there's a little bit of code finds that none of the BSDs return the same error message for the same problem. Although a NetBSD user notes here that when they ran it on NetBSD's head, which I guess is what's going to be NetBSD 9, that it reports OpenBSD, not NetBSD. So maybe there's been a behavior change there.
Mm-hmm. Yeah, it's not
or the code is wrong.
foolproof, but for a quick detection, then it's certainly interesting.
It's interesting just to see that FreeBSD, OpenBSD, NetBSD, Dragonfly, Minix, and Linux have all managed to be that different in what happens when you try to open and close a UDP socket. Doesn't seem like that's a good thing, honestly.
Yeah, it's well, let's leave it at that.
Yeah. So this week's feedback segment is brought to you by Tarsnap. Head over to tarsnap.com/BSD Now to get started doing your backups, because you really want to do your backups.
Yep. And of course, you're truly paranoid about your backups, because if you want to store them in a secure way into the cloud, which has a lot of storage space, you want to make sure that you're the only person holding the decryption keys. And the way to do this is to encrypt locally before it goes into the cloud, and the cloud will only ever see your encrypted backup files. And the key
so they
stays...
won't be able to tell what's in the backup.
Yep, and you're the only person who can decrypt that with the key, so don't back up the key into the cloud yourself, because that would defeat the purpose. But Tarsnap makes it easy. It has a command line utility. It has also GUI now, and there's a lot of documentation. There's also a book by Michael W. Lucas about Tarsnap, so everything that you need to know. And to get started doing backups with Tarsnap is easy, and it only costs you less than $5 a month.
Yeah. So you really want to do your backups, and it makes it really easy to do them frequently because it segments, deduplicates, compresses, then encrypts, so that your files, you're not sending the same data multiple times, so you're not paying to store data that's already stored.
Mm-hmm. Yep. Okay.
So, question time.
Yes.
As if I haven't answered enough questions.
Yeah, you're already pretty much dried out with answers. But yeah, this one is from Awesome Mike. He has two ZFS questions. He writes, question 1. Recently, I upgraded one of my storage devices to ZFS. I wanted to copy files onto the dataset /mnt/pool0/backup, but made a tiny mistake and found it copying my folders in mnt/pool0. Thus, I aborted the copy process, corrected my mistake, and started copying into the dataset /mount/pool0/backup. Now, I was wondering if this could have led to problems had I not corrected this, and what is the difference between a folder being made in pool0 and a dataset?
So putting files in the root of the pool will not break anything. It's perfectly fine. The difference is when you make a dataset, it's a separate file system. So if you move files between two folders on the same, or directories on the same file system, it's actually just a rename operation. It's very fast. However, if you have two different datasets, which are separate file systems, and you move a file from one to the other, you actually have to copy it, and then when it's done, delete it from the old one. And so that means it takes a lot longer, rewrites all the data. And if you have snapshots, when you delete it from the source file, it's not actually deleted yet until you get rid of the snapshot where it existed. So it can actually take up twice as much space. So there's no real problem with having it in the root of the pool, but it wasn't where you wanted it, and it would have been more work to move it after. In general, I like to use datasets on ZFS, quite a few of them, to try to logically group my data, because when you do other ZFS operations, like a snapshot or replication, the granularity that you can select is the dataset. So, picking a dataset, I group my files into datasets, and I try to not have any dataset bigger than, 400 or 500 gigs, so that if I want to do replication or whatever, it's not such a big chunk where I don't get to pick which files I want to replicate and which ones I don't.
Mm-hmm.
So yes, it wouldn't hurt anything, because the root of the pool is basically just another dataset. But I like to have quite a few datasets. A nice thing about ZFS is the number of datasets doesn't impact the performance of ZFS. It may make it take slightly longer to do ZFS list to get a list of the datasets, but the read and write speed of files and so on will not be impacted whether you have 0 datasets, 100 datasets, or 10,000 datasets.
Yeah. So datasets is the way to go. Second question.
And so the other thing with datasets is you can have different properties. So you can have one that's compressed and one that's not, and so on. Or, when we talked about the benchmarking, I like to do a new dataset for each benchmark because it's easy to throw it away and get a fresh one every time and not have any leftover stuff.
Yep. So his second question goes, hard disks have a certain size, but these vary per type and manufacturer. But to claim a disk has a certain size, like 1 terabyte, this should mean that the device holds at least this amount in raw space. Is this correct?
Not really. Usually the sector count is pretty close, but it isn't always exactly the same.
Yeah, it's he writes further, I was wondering why we don't use the advertised size, which is not divided by 1024, to create a GPT partition for use with ZFS. Replacing a disk would always be good unless you put in a smaller one. Of course, we could also leave 1 gigabyte of free space at the end of a disk to compensate. As I did this thinking in my first ZFS encounter, I'm sure my thinking is too simple. Could you please elaborate on this?
In general, yeah. What I do is when I partition the disk, I use the -a flag in G part to align it to some reasonable number, like 1 megabyte or something. And yeah, I create a swap partition on almost all of my disks also. And so I could always shrink that if I needed to rearrange the space. But yes, just not using the last gig or, doing the aligning it so that whatever fraction of a gig is left at the end of the drive isn't used will protect you. But in general, the difference between like a bunch of different 6 terabyte drives is probably not going to be more than a couple of sectors. In most cases, it's just that if you have 4K sector disks instead of 512 byte sector, then, if it wasn't a number divisible by 8 on the 512 one, it might be 1 sector less or whatever. So you probably don't need more than a megabyte of slack to deal with. So just doing -a1m to align it to 1 megabyte boundary will probably give you enough slack. But it doesn't hurt to have that gig. I like to leave a good chunk of swap because sometimes you need a bunch of swap. Or at least even just a scratch space to put something temporarily or something. And, I'm not going to miss a couple of megabytes or a couple of gigabytes on a 6 terabyte disk if I have 6 or 12 of them in a server anyway.
Yep.
Yeah.
That pretty much as the more experience you get with ZFS, these questions will pretty much evaporate. Or if you have further questions, then check out the ZFS books or send us a follow-up question. Like this one, we have had this question in an earlier episode. And awesome. Here's a follow-up to one where you provide a little bit more information via IRC. So the original question basically was about rebuilding a hardened BSD server at home with a similar drive being available.
So they have ZFS on a 1 terabyte drive, and they found another similar drive that wasn't in use, and they saw that it could create a mirror and add the new drive for redundancy, and ended up with... He's got his 2 partitions, and they're the same size. I needed more disk space, so I purchased 2 4 terabyte drives, but because of the way I created the mirror, I was not sure how to proceed with the configuration. What are my options? And then...
Yeah, here's your IRC response.
Right. So you could just add the 2 4 terabyte drives as a second VDEV to your existing 2 1 terabyte drives, and you'll get the more IOPS that way. The only downside might be that your current drives are mostly full, and so a lot of the writes were going to go to the newer drives. So if you're not in a hurry, what you could do is first replace one of the 1 terabyte drives with a 4 terabyte drive. Once that resilver is done, do the second one. Now your pool can grow and you have a 4 terabyte mirror and 2 spare 1 terabyte drives. Now these drives are empty and can be added as a new VDEV to the end, giving you back that extra terabyte of space. But now you have a 4 terabyte VDEV with 1 terabyte data on it and a 1 terabyte VDEV with no data on it, and they're a little more even and your writes will go to both of them. The 4 terabyte will still take a bit more of the writes, but you might get slightly better performance for doing it that way. And then down the road, you could replace the 2 1 terabyte drives with 2 8 terabyte drives or something, whatever size makes the most sense when you go to do that years from now.
Yeah, without downtime or having to completely copy all the files back and create a new pool. It's all done live and running the system.
Yep. And if you have enough slots to connect, obviously you have enough slots to connect all 4 drives at once. So what you could do is just put the new 4 terabyte drives in and then use the zpool replace commands, which will do the resolver thing online. So it'll keep the old hard drive and the replacement hard drive online while it copies all the data instead of having to do it from parity. So that means you can replace both drives at once. And even if one of the new drives were to die, you're not endangering your pool because you've still kept the original device online. So unless the resolver completes, the old device doesn't go offline yet. So hook up the new drives. Zpool will replace the first drive with the first new drive and the second drive with the second new drive. When it's done, you can use Zpool add to add the two old drives as two new drives, basically. And then you'll have your new 5 terabyte mirror pool with more balanced free space.
Yep, everyone will be envious that you could do this. Yeah, very nice.
And thank you to Michael Shirk for writing in that question for us.
Yeah, so this
After I helped him on IRC, I was like, you have to write this in as a question for the show. And he did. So thank you, Michael.
Mm-hmm. Yeah, I guess many people will face this once they have a ZFS running for years now, and drives become cheaper, and they want to switch those. So, yeah. Good thing to have this.
Yes, the fact that ZFS can do Zpool replace if you can connect all the disks at once, meaning there's no danger, whereas if you pull an old drive out and put the new drive in, depending how much parity you have, if the new drive dies, you could, if one of the drives you're reading from and the drive you're writing to both die or something, you could end up in trouble, whereas with the online replace, you don't have that problem.
Yep, but yeah, it's cool that we can do this with ZFS. The last question is also a ZFS question from Brian about optimizing ZFS for a single disk. So he writes, "Hello Benedict and Alan, I decided to dip my toes into the ZFS ocean by using it for the /home partition of my new desktop computer. I would love some input and recommendations for optimizing ZFS running on a single disk pool on Linux, Ubuntu to be precise, using a spinning hard drive. As always, keep up the good work."
There's nothing you should need to do. There's nothing really special about having a single disk. The very first hint is, well, it's a desktop, so get a second disk and mirror them. You can add the mirror after the fact, right? You just do the zpool attach command, and you'll be able to add your second disk to your first disk, and it'll turn it into a mirror, and it'll all be happy. Other than that, there's no special settings or anything you need to do. I know some people would talk about using copies equals 2. That protects you from a bad sector or something, but hard drives nowadays, you're more likely to lose the whole drive stop working than to have a bad sector. And so cutting the size of the drive in half by setting copies equals 2, probably not that worth it. Maybe, but probably not. Up to you. If you're not running low on space, then it can be fine to have copies equal 2, I suppose. Just remember that you can't change it to copies equals 1 later and get back half the space.
No.
Rewrite all the files or whatever in order to actually shrink it.
Yeah, I would activate compression, of course, and the record size depending on what kind of files you store on your home.
Yeah, in general, for your home directory, it's probably mostly bigger files, so the defaults are probably fine. You're probably not modifying the middle of existing files very often to worry about record size too much.
Yeah, no deduplication doesn't make sense.
Don't
probably
use dedupe.
to have that, and switch off the access time.
Yeah, you might want to turn A time off for your home directory, but in general, there's nothing special you do just because there's only one hard drive.
Yeah, it's the same as if you have multiple.
ZFS is designed to make the storage administrator's life easier. So in general, there's nothing you need to do. There are sometimes things you can do specific for your workload or your computer or something to make it a little bit better. But in general, everything just works. And that's half the fun of ZFS.
Yeah. So thank you for sending in these questions. And yeah, that's the end of the show for this week. Thanks for sticking with us. And next week we'll have another one. Thanks for listening, and see you next week.
Yeah, so when you watch this episode, we'll have recorded it 3 weeks ago? 4 weeks ago.
Back in the day.
Yeah, when you watch this, we'll have recorded it 3 weeks ago. But we did that so that you would have an episode every single week without missing any. And like someone said in one of those questions about me using my regularity, that'll be a total of 519 podcasts that I've recorded without ever missing a week. Although a little bit of that overlapped, so it wasn't actually 519 weeks in a row, but getting pretty close to 400 weeks in a row.
Yep.
That's a bit ridiculous.
Yeah, you think about it, yeah.
Anyway, thank you for watching, and we'll see you next week.